Hello all, welcome to your 3-5 flip video. 3-5 is percent increase and percent decrease. So basically it's one equation, which is really nice since that's only one new equation, that tells us about what percentage of an original amount a scenario rather increases, so our number goes up, or decreases, our number goes down. So an example of percentage increase would be if you're at low tide and the water increases at high tide, so then the water level increased. An example would be decreasing would be like if a company had made some profit in the year 2000 and then in 2010 their profits decreased, so you can figure out the percentage decreased, okay? This is something that adults even struggle with. So it's nice that you guys seem to have such a firm grasp. Percent decrease, or percent of change, is the amount of change, so the change quantity over the original quantity or the original amount, okay? So basically percent change is the change over the original, okay? So let's dive into the amount of change really quick. You might have heard this in class or in a science class. To find the amount of change, you take your end point and you subtract your start point. So in science, you typically hear this as final minus initial. You know, if you fill up a balloon and you put 10 breaths of air into it, and it started off with 0 breaths, well, your final was 10, your initial was 0, so you blew in 10 breaths, so the change, the difference is 10 minus 0, your end point minus your start point, so you added 10 breaths. If you started off with 1 breath of air already in there and you went from 1 to 10, you know, 10 is your end point, 10 minus your start point, 1, so 10 minus 1 is 9, you added 9 breaths, okay? So final minus initial, or end point minus start point, they're both the same thing, okay? So here, let's have an example. I have a flower that's 1 foot tall, and then it gets sick because it's winter, and it starts to wilt, and it drops down to half a foot tall. So we can figure out the amount of change by doing end point 0.5 minus 1, the original start point, so 0.5 minus 1, which is negative 0.5. And I know what you must be thinking, well, that's not very useful. I can't have a negative percent of change. You have percent of change, and either it increases or decreases. So what we can do is we can change our equation a little bit, and we can add absolute value signs. And in case you don't remember, absolute value is the distance a number is to 0 on a number line. So 4, for example, 4 is 4 units away from 0, so the absolute value of 4 is still 4. Negative 5, to find the absolute value, if you were to draw out a number line, negative 5 is 5 whole numbers away from 0. So the absolute value of negative 5 is 5. So a quick little trick to find absolute value is just, if it's positive, leave the number alone. If it's negative, make it positive, okay? So if we put absolute values around our amount of change, we're guaranteed that they're always positive numbers. So this is helpful because if I put absolute value around negative 0.5, it just turns into 0.5. And you're like, well, duh. If it started at a foot and it dropped to 1 foot, how much did it change? It changed by half a foot, so 0.5 feet, okay? So your brain is already kind of doing this. I'm just putting math symbols behind it, okay? So I don't want us to get confused with the absolute, but I want you to know what your brain is doing and why the numbers work out that way, okay? So if you're able to say, starts at a foot, drops to half a foot, it decreased by half a foot, that's fine. If you want to do absolute value symbols and do it that way, so if it helps your brain to write it out, that's fine too. So this is all 3-5 is. It's just percent increase and percent decrease. So I'm going to do 3 homework problems, and then that's it, okay? So here's a homework problem. And if the original quantity is 20, new quantity is 16, what is the percent decrease? So let's highlight information. Original 20, new 16, percent decrease. So percent change is change. So if I start at 20 and I go to 16, I changed by 4, and you could do final minus initial. 16 minus 20 is negative 4. Take the absolute value, positive 4. So 4 over my original quantity, 20. So 4 over 20. And then we go into our calculator, gives us 0.2. Now, this is not our final answer. This is our percent in decimal form, and you'll remember that in order to take a decimal number and put it in percent form, you move your decimal point 2 places to the right. So it's originally on the left, we swoop it once to the right, so now we're on the right of the 2, and one more time, fill in the 0. So 0.2 is 20%. So it decreased by 20%, so a 20% decrease. All right. Craig likes to collect records. Last year he had 10 records in collection. Now he has 14. What's the percent increase of his collection? So let's highlight important information. 10 records last year, 14 records now, percent increase. So percent change. How much did it change? Well, he started at 10, then he went to 14. So final minus initial, 14 minus 10, had an increase of 4 records. I'm going to switch the number here just because the last problem we also had a change of 4. So let's switch it from 14 to 17. So how do you go from 17 down to 10? Well, you changed by 7, okay? So 7 over 10, which is 0.7, and we're going to do the same trick. We're going to move the decimal point 2 places to the right. So my percent increase is 70%. He increased by 70%, okay? Last one, Sarah ordered 14 large pizzas for a party. When the party was over, she had 4 large pizzas remaining. Estimate the percent change in the number of large pizzas. So highlight information, 14 large pizzas, 4 large pizzas remaining. Estimate the percent change of large pizzas. So percent change, if you start off with 14 and you have 4 left over, you ate 10 of them. So 10 is my change over my original 14. All right, and now I'm going to back up a second. Let's pretend this was Niwa. Let's say this was all you need. You had no idea how to solve it. How could you get rid of some bad answers? Well, if you ate 6 pizzas, is that an increase or a decrease? Well, you're decreasing. So we can get rid of all answer choices that have an increase because those can't possibly be right. So I can get rid of A and C, okay, because both of those say increase. So really I'm looking at either 75% decrease or 50% decrease. So let's do 10 divided by 14 on our calculator, which is 0.71 roughly. 0.71 roughly. So if you move your decimal point 2 to the right, it turns into 71%. And so the question is asking which of these is the best estimate for percent change? Well, 71 is much closer to 75 than 50, so our correct answer is B. All right. Also notice that percent change, they use the term percent change here instead of percent increase or percent decrease. You can think about percent change as kind of like an umbrella. All right, here's our umbrella. This is percent change. Under this umbrella, the 2 categories underneath it are percent increase and percent decrease. So if you see the word percent change, it could be percent increase or percent decrease. Okay, nice short video. If you have any questions, let me know.